talk about evaluating algebraic expressions. So, first of all, what is an expression? We know about equations. Equations are things like this. X plus 5 equals 10. Or 2/3 x equals 8. These are equations. Expressions would just be half of that. X plus 5. Or 2/3 x. Those could be expressions. That's what we mean. So an expression has no equal sign. An equation, equa, has an equals sign. That's where we get the difference. So an expression is like x plus 5. So when I say evaluate an expression, here's an example of a problem.
For some reason, evaluate sounds like something that's really bad. Like, evaluate that person for...
Right. So if I had the problem x plus 5, and I said evaluate x plus 5 when x equals 6. All that means is I'm going to do what I like to call plugging in. Plug it in. I'm going to take my 6, use a different color. I don't know how well this will show up on the video, guys, but I think it's useful now. So I'm going to take this 6. That's equal to x, right? Where's x over here? Look, I found it. Here's x. Take my 6, and I'm going to put it right there in my expression. So instead of x, I'm going to write 6 plus 5. Right? And an equivalent expression to 6 plus 5 is 11. 6 plus 5 would be 11. So my final answer would be 11. Notice it's not x equals 11 or anything like that. It's just 11. Because x equaled 6. I knew that from the beginning. I put that in here and I got 11. Okay? Let's do a few other examples. It said, I'm going to give you one thing. Evaluate when x equals 6. And I'm going to give you several problems. So the first one is 2/3 x. The next one is 1/2 x plus 7. The next one is 12 minus x. And then let's do -4 plus x and -1/2 x. Alright, so we're going to take the 6. We're going to plug it into each one of these expressions. So the first one, we're going to have 2/3. Where I had my x, I'm going to usually put parentheses. So I'm going to put my 6 in parentheses. In this case, it doesn't really make a difference. All I'm going to do is 2/3 times 6. when something is next to x, it means multiplying. So 2/3 times 6. Another way of writing that might be 2/3 times, I could put the 6/1. Would make it easier. Cross out the 3, cross out the 6. So I have 2 times 2. My final answer would be 4. Again, let's do this one. Put my 6 in where I had my x. What is this going to equal? 1/2 times 6 would be like, we could write it two ways. 1/2 times 6/1. Or we could just write it as 6/2, since these are both 1s. Plus 7. Now do I do the plus 7 first or the 1/2 first?
Plus 7.
Think about our order of operations. Parentheses, okay, nope, nothing in the parentheses. Exponents, no exponents. Multiplication. So this, when we see 1/2 x, that is multiplication, right? This means 1/2 times x. All right, so we've got 6/2, or 1/2 times 6. What will that equal? 1/2 times 6, or 6/2. They're the same thing. 2 is going to cancel with the 6, leaving us just a 3. So I have 1 times 3/1 plus 7, which is 3 plus 7. What's my final answer? I'm not sure if I'm writing big enough for the camera. 3 plus 7 would be 10. Let's erase this so I can write the next one a little bigger. Still x equals 6. Still using x equals 6. In this case, 12 minus 6. Right? And I could put this in parentheses, but it doesn't affect anything, because there's just one number in the parentheses. So either way, it's 12 minus 6.
So it's always
Which,
6.
well, in this one I said x equals 6. So in all these examples, x is 6. But it won't always be. What is 12 minus 6? 6. Okay. In this one, what am I going to rewrite this as? Since I know x equals 6. -4 plus 6. Very good. What does -4 plus 6 equal? Well, I can't really do this, right? Because I have -4 and a positive 6. So think of it like this. 6 minus 4.
-10.
Think of it like this. Flip it around. Positive 6 plus -4. Instead of -4 plus 6. I can flip that around. 6 minus 4. So what does that equal? 6 minus 4. Yeah. This is equal to this. So this is 2. -4 plus 6. If you think about that on the number line, here's 0, right? We start at -1, 2, 3, 4. We start right here. We're going to go 6 in the plus direction. So we're going to go 1, 2, 3, 4, and we're at 0. And how many more beyond that? Yeah, 5, 6. So 2 more. End up being 2. Okay? So the answer to that one would be 2. And then here we have -1/2 of 6, or times 6. What's the answer to this one going to be? There's two ways to think about it. We could think of it as -6/2, just bringing this up, times our numerator, which is 1. Or we could think of it as -1/2 times 6/1. Either way, want to see some canceling here. And my final answer will be negative 3 over 1, which is just, what is negative 3 over 1? Just negative 3. 3 over 1 is 3, negative 3 over 1 is negative 3.
That's a lot of work just to come up with a simple answer.
Right. So we're simplifying is really what we're doing. We're simplifying. All right, let's do some examples. I'm going to let you guys do these ones. The trick with these types of problems is that there's a lot of different operations involved. So you have to remember PEMDAS. You have to remember multiplying fractions, all that kind of stuff. So evaluate 4x plus 2 when x equals 2. Evaluate, this will be example number 2. 3y minus 1 when y equals 9. Example 3, evaluate 1/4 z plus 16 when z equals 8. All right, talk me through this first one here. I'm going to plug in what number instead of x? 2. So I start with 4x. What am I going to write instead?
4 over 2?
Is it over x?
Oh, no, it's next to that.
Yeah, so I'm just going to put parentheses for the 2 inside. Well, what does this mean, 4 parentheses 2? Exactly, 4 times 2. And then don't forget about the last step here, plus 2. Now what am I going to do first, the 2 plus 2 or the 4 times 2?
4 times.
Yeah, multiplication. So what is 4 times 2?
8.
8 plus 2 equals 10. I did that one pizza slice style, right? Going down, getting simpler. Alright, now the next one. 3y minus 1 when y equals 9. What am I going to rewrite this as?
3 plus
3 times 9, because 3y means 3 times y. Minus 1. Okay, let's just do an equal sign. What is 3 times 9 minus 1? 27
6.
minus 1, which equals 26. Okay, I did that one in a line. You can do these either way, right? Either way, I'm just saying this step equals this step equals this step, or this step equals this step. All right, last one. I'm going to write 1/4. Then what am I going to write? Times 8. Very good. What is 1/4 times 8? Oh wait, should I do the 8 plus 16 first?
No, you should.
No, because that's,
under 8.
yeah, still multiplication over here. 1/4 times 8.
You could do 8 over 1.
Yep.
So I could make this 1/4 times 8 over 1. Don't forget your plus 16, which is 8 over 4. What is 8 over 4?
Oh, 16. Wait, negative
Yeah.
16 and
8 over 4 means 8 divided by 4.
Oh.
2.
Yeah, so this is just 2. Or I could think of it as canceling out.
Then it's 18.
Either way, it's 2 plus 16. Which equals what, Luca?
18.
18. I did that one kind of messily, but at least you can follow it, right? I drew an arrow to go up here, and then I have an equal sign, and I circled my final answer. Right? All right. I'm going to make it slightly more complicated.
Nah.
What if I said, what if I said going to do?
You're gonna
Same thing.
Yeah.
Okay, so what am I going to rewrite this as?
2 times 4
Good.
plus 3.
Very good.
First do the 4, 2 and 4, and you get 8 plus 2 is 10. Then your answer will be 10.
So 8, 9, 10,
11.
11. Very good. Okay, what if I said now when x equals negative 1 and z equals 5? So we're going to take the same expression, but we're going to evaluate it with those numbers. What's my first rewrite going to look like?
2 times negative 1 plus 5.
Very good. What is 2 times negative 1?
2.
Negative times a positive is a?
Negative.
Good.
Negative
Plus 5. Okay, negative 2 plus 5. So I'm over here at negative 2. I'm going to go 5 that way. 1, 2, 3, 4, 5. What number is that? Yeah, here's 0, 1, 2. So this is a 3. Okay, one more. Same expression. When x equals 1/2 and z equals negative 3. What's my first rewrite going to be? This expression. Very good.
Plus negative 3.
Yeah, plus negative 3. Okay, first step.
2 1 over 2.
Okay, so 2 over 1 times 1 over 2. If that helps you to think about this.
Equals 1.
I'm going to say plus and negative 3. Good, Luca saw that these are reciprocals. So this is going to be 1.
Actually, what I did is just multiplying.
What is 1 plus negative 3? Is there a way we could rewrite that?
Plus, it's going to be negative 2.
So plus a negative is minus, right?
Yeah.
So 1 minus 3.
Is
Or if you already saw it, some people already said it, negative 2.
negative 2, yeah.
Right? Because we start at 1 and we have to go 3 in this direction. So 1 gets us to 0 and then 2 more. Or we think of it as 3 minus 1, negative. Flip it around. Negative 2. Alright. Last part of the lecture.
You said that was the left.
I did?
Yeah.
I don't remember saying. Last part of the lecture.
Better be.
You guys ready?
Remember.
Here we go. Solve x plus 5 equals 10. Then check your work. So, if we have x plus 5 equals 10, we know how to solve that,
That's
right?
how you spell your.
Yeah, it is.
Y-O-O-R.
No, we spelled Y-O-U.
That's a U?
That's a U, I'm sorry.
Oh. I was like, that's not a U.
Thank you, you'll save me on the video. No one will put any bad comments now. You spelled your wrong. Alright, x plus 5 equals 10. So what am I going to do?
Minus 5 minus 5.
So x equals...
5.
Okay, now look, I have x equals 5.
Add 5.
I'm going to take this and I'm going to plug it into this expression to check to see if my work is correct. Okay, so here's my answer. X equals 5. Now I'm going to check. So to check, I'm going to rewrite this expression. Instead of x, I'm going to put 5. So what will that look like?
5 plus
5 plus 5 equals 10. Is that true?
Yes.
Yeah, so it checks. I know I got it right now. Okay. Let's do 3 examples like that.
But what you said the last one was the last one.
This is the last thing.
But you said,
But we're going to do examples of it.
you said that it was going to be the last thing we were going to do. This is going to get that compromise.
Example 1, example 2, example 3.
Nay,
All right,
you're killing me.
first one. So what I want you to do for all of these, solve and check. All right, 2x equals 4. X minus 9 equals 1.
We take turns on these ones.
Actually equals negative 1. And then we're going to do 4/5 x equals 20. Okay. To solve, first let's solve this first one. Ready? How are we going to get rid of this 2 in front of the x? Good. Divide by 2. So then we have x equals 2. Now we're going to check that. So here's my answer, and then here's my check. I'm going to say 2 times 2 equals 4. Is that true?
Yeah.
Yeah. I don't like that marker. Let's try this one. What am I going to do?
You're going to add 9.
Add 9 to
1. Negative
both
1.
sides. So I have x equals 8. I think that's my answer. Now I'm going to check it.
So it's 8 minus.
Good. So check 8 minus.
1. Like 8 minus 9 equals 1.
9 equals negative 1. Is that true?
Yeah.
That's true. Negative 1 equals negative 1. Last one. How are we going to solve this?
By dividing 4/5.
Yeah, dividing 4/5, in other words, multiplying 5/4. Right? I think it's a little easier to think of it like this. So when you have a fraction, use its reciprocal. Right? Multiply by the reciprocal. So this is going to cancel. 4/5 times 5/4. Right? We have 4/5 times 5/4. The 5 cancels the 5, and the 4 cancels the 4. All we have left is 1x, or just x, equals 20 times 5/4. Let's put the 20 over 1, if that helps you to see this. 20 cancels with the 4, leaving us 5. Now we have what over here? 5 times 5, which is 25. Now I'm going to check that. So here's my answer. Here's my check. To check, I'm going to plug it in. 4/5 times 25 equals what? What was the original problem? 20. Okay. So what is 4/5 times 25? A helpful way might be to put that 25 over 1. Yeah, we can cross out the 5, and what's left up top here? 25 divided by 5 is 5. So we have what's left here? 4 times 5 equals 20. Is that true? Check. So it's true. Now what if it weren't true? Let's say we plugged it in and it's not true. What does that mean? We did something wrong when we were solving. So let's take a look at this. Let's say I got, in this problem, x plus 9 equals negative 1. Let's say I said, oh, yeah, well, x plus 9 is negative 1, must be 10. X equals 10. So let's try plugging 10 in. What's going to happen? I'll have 10 minus 9 equals negative 1. 10 minus 9 is 1 equals negative 1. Is that true? No. So then what I would do is go back to my original problem and resolve it. Okay, plus 9 on both sides. Okay, x equals negative 1 plus 9. 8. Oh, it's 8. Then check it again. So you're checking your work to make sure that you're getting the right answer. If this isn't true, go back and solve the problem again. Okay?
It's not true
Then you have to keep trying. Yeah. You get it, eventually you'll get one that's true, right? I mean, you guys have gotten them pretty much the first time with a little bit of my help, but you talked to me through those problems. So you guys got them the first time, and checking your work just helps you make sure of that. All right. Questions? More